Friends, and welcome to my channel. It's been a while since we've done a PLC programming live stream, or where we're just going to sit here and do some programming and talk some things out. Now, a little bit of housekeeping. Michael is now in Finland, so I don't have my trusty sidekick to keep track of chat, and Amber's on the road too today. So still drop your questions in the chat. But what I'm going to do is I'm going to do some programming for a while, and then I'll break off and do some chat questions. And so we are going to be in Studio 5000, and we have our PLC trainer already wired per the Getting Started guide. And just in case you need that, let me go ahead and put that down in the chat here. So here is the wiring diagram. And we're going to start off with a new copy of Studio 5000. And if you're using one of our standard trainers, it's going to be a 1769 L16ER BB1B, and that's one of the 5370 controllers. I'm actually using an L18ER because just needed a little more memory for some of the things we were doing here. We're just going to call this timers and counters. Next. And then we're running version 32, and we're going to have 2 expansion modules. And we'll click Finish. And let's go ahead and fill in some descriptions on these controller tags. So on our inputs, we have the green button. Actually, whoops, hit the wrong thing. So yeah, the green button, or button 1, is going to be input 0. Button 2 is going to be input 1. Button 3 is going to be input 2, and so forth through there. So let's go and put some descriptions on them and check them out. Like this button 1. Or actually, we'll make it a green button. That makes it a little easier. Green button, yellow button, red button, blue button, and switch 1. Those are the main ones we're going to be using. And just to check them out, I'm going to hit the green button, and we see that we get a 1. Oops, no, we don't, because I haven't even downloaded the program yet, guys. Got a little ahead of myself already. So let's go to communications, who active. And I have not put a program in yet. We're going to do this one online just so we can talk through things, because we're going to slowly build this out. So we'll select you, download. Sound is very low. Okay, well, thank you. Let me move that up, and let's just move this up. Does that make my sound better? Okay, so now if I press the green button, we're going to get a 1 in input 0, yellow, input 1, red, input 2, blue, input 3, and switch 1. And go ahead and do those checks when you do this exercise, because you'd be surprised the times that you find out that your code's not working because your wiring's not right. And so we're also going to be using our lights on this one. And light 1 is going to be output 0, light 2 is going to be output 1, light 3 is going to be output 2, and light 4 is going to be output 3. So I'm going to go ahead and put those in there. Green light, yellow light, red light, and blue light. And we can actually check those without even putting any programming in. So I'm just going to put a 1 in the green light box. And when I hit enter, we get a green light, and then yellow, yep, and red, and blue. All right, so I think we are all set on that. And then let's go on into our programs. And I always tell people, you get lost and you can't find your program, because really when you open it up, it does look like a blank blue screen like this. Find task and work your way all the way down through it. And always hidden right here under main program is going to be our main routine. So we're going to open it up. And we're just going to start off bringing down a go look for a 1. And then we're going to go to the timer counter tab and bring down a TON, timer on delay. And we're going to use switch 1 for this, just so we can work our way through it slowly. We can hold it on. Switch 1 was input 4. And over here, I'm just going to call this my first timer. And then I tell my students all the time, anytime you type words, you got to tell it what it is. And we're going to right click in new to do that. And 80% of the time, this is going to be correct. We're just going to hit the create button. And now that you don't have questions marks there, we can enter values. So I'm going to enter 10,000 for our presets. And then let's go ahead and put that into our program and just see what it does. So I'm going to switch 1. Whoops. Now let me switch 1. And it times up. And when it gets to 10,000, we're going to see the done bit. Now, most people stop right there and say, okay, well, now I know how a timer works. But no, we don't really know how the timer works yet. And this is what I tell people all the time is don't dance around and think, oh, well, now I know the TON. Let's go on to the counter thing. So you need to take your time and go through each one of these and understand each bit of them. So first thing we did is we right-clicked first timer and we selected new. Well, when we did that, we created a structure. And so let's go right-click first timer and let's monitor it. And anytime we see an arrow, we're going to click it, and that's going to open it up. And now we can see the actual values in them. And oops, I didn't notice I've got the wrong sorting order. Let's uncheck you. This is the default sorting order. So we have a PRE, an ACC, an EN, a TT, and a DN. And we want to go through and understand each one of these. And to make it easier, I like to bring them down to light so we can actually see what's going on. So we're going to bring a new rung down. And we're going to go to our favorites tab and bring a go look for a 1, examine on down, and an output energize down. And this time we're going to follow our arrows and go to first timer. And we're going to bring the EN in. And for this output energize, we were going to go to local :1:0 data and 0. That's our green light. And now let's just right click it and let's copy that rung. And we're going to right click and let's paste it a couple times. And on the second copy of it, we're going to take the TT bit, and the third one, we're going to use the DN bit. And we're going to look at the yellow light. And the red light. All right, before we go any further, let me go and say hi. First of all, hi, Amber. I believe you're on the road now, so hope to see you soon. Max Carpenter, thank you. You've helped us at the mill again on produced and consumed tags. I wish you the best. Have a good one. Well, I'm certainly glad I could help you out there, Max. See, Turinator. Thanks for hosting the live chat. Yeah, and the craziest thing YouTube has done lately, it's kind of cool. They've given us this little emote thing so we could throw emojis onto people's comments. The only issue is it's right at the bottom comment where I can't see the bottom comment unless y'all actually keep throwing stuff in. Hey, Mom. Very good to see you. I hope my sound's okay now. Hey, Tom. Good to see you. I just saw you over on LinkedIn. Hey, Henry. Very nice to see you. And the one complaint we've had on the last 3 live streams is people are like, well, I didn't even know this was happening. Well, you know how you're going to know what's happening is go ahead and hit that subscribe button and tap that bell, because these are not regularly scheduled. I know everybody keeps saying, well, why don't you just make a regularly scheduled live stream? Well, we do classes at 2 weeks and then we're off for 2 weeks. So I like the during the day live streams. I think it gives you an opportunity to practice while you have the equipment in front of you. But also, I want to come to you on those training weeks when we can't do that. But all right. And here we're going to do one more because also we had that accumulated value. So let's bring down on one more new rung. And this time, whoops, and I did it anyway. I was getting ready to tell you, and this time don't do that, and I did it anyway. So we're going to go, this time we're going to go to the compare tab, and we're going to bring down a greater than instruction. And our source A is going to be first timer, accumulated, and on the source B, let's just make it 5,000. And then let's go back to our favorites tab and bring down our output energize. And this time we are going to look at which one, I'm going to try to show you shortcuts as we're going through here. I don't know if y'all know this, but if you click the words, when I say the words, I mean the actual tag, you can actually drop it in any of these cells. Now you got to be really careful because you see even there, it kind of goes all crazy on you a little bit, but I can drop that right here. And then I can change that 2 to a 3, and that'll be our blue light. So let's put that into our PLC. And okay, right away, we have a green light, we have a red light, we have a blue light. And that is because this timer is done. But what I like to say is let's just fixate on one at a time. It's just the biggest struggle for the technicians that come to my class because you feel like you've got to observe every single thing, all the time. But I just want us to focus right here on rung 1, this enable. We're going to look at this green light here. So I'm going to switch 1 off, which is going to make that TON false. And then I'm going to switch it on, and immediately we get that green light, which is that enable. And we can see it timing up, and we're almost at 10,000. And when we get to 10,000, our enable is still on. Our green light is still on. So the green light simply means that the instructions preceding our TON are true. So this instruction right here goes and looks for a 1, where at switch 1, or local colon 1 colon I.data.4. And you can mouse over it and get a quick peek, and we see its value is 1, so it is true. And that is going to make the enable a 1. I switch 1 off. This instruction goes and looks for a 1. We mouse over it, we have a 0. So now it is false, and our enable is a 0. So next, let's do the same thing with the TT bit. And so right now, our switch 1 is off. We are disabled, and our TT is 0. And the moment that I switch 1 on, the yellow light comes on. And if we look over here, our timer value, our accumulated value, is moving up. Now, as soon as it stops moving, you see the yellow light goes out. And that TT stands for timer timing. And so it simply means that our accumulated value is going up, or the instructions preceding the TON are true, and the accumulated value is less than the preset. Next, we have the red light, and currently it is on because we have a DN as a 1. And the DN does stand for done. And right now, switch 1 is on. I switch 1 off, and our done goes out immediately. I switch 1 back on, and our timer is going up. Our red light is not on, but as soon as we hit 10,000, our red light comes on. So it means the instructions preceding the TON are true, and our accumulated value is greater than or equal to the preset. Now, a lot of people think that all you can do is look at these little bits here, but no, we can do comparisons also. And that's why I always like to put this in here, right? So we have a greater than instruction, and this is going to simply compare that our first timer accumulated value is greater than 5,000. If it is greater than 5,000, this will be true. If it is not, it'll be false. So right now, our accumulated value is 10,000. That's greater than 5,000. Our blue light is on. I'm going to switch 1 off, which is going to make the TON false. And that takes our accumulated value to 0. Blue light goes off. switch which one back on, and our timer is going up. And when we get greater than 5,000, the blue light comes back on. Now, I always like to pose this question at this point with my technicians when they come to the class. And yes, obviously, you're getting ready to hear the answer, but think about it before you go on. Even pause if you need to. Is what does a false TON do? Because this is an important part of understanding ladder logic that I find a lot of people skip over. Is we think, well, if it's false, it does nothing. Well, no, it does something. And when we look here, right now it's true. Our EN has a 1 in it. Our DN has a 1 in it. And the first timer accumulated value has 10,000 in it. The moment I make switch 1 go false, our EN goes to 0, our DN goes to 0, and our first timer accumulated value goes to 0. And a false TON does exactly that. It writes a 0 to everything except the preset value. And that seems like a small deal right now. But when we convert it over to an RTO, it becomes really important because it makes you associate them really well. But also, when you're troubleshooting machines, if you just glaze over everything that is false, then you could blow right past what the actual issue is on the machine. But all right, that pretty much covers the TON. Now, the next one is the RTO instruction. And although actually, if we go to the timer counter, we notice the next one is a TOF. But the RTO and TON are really close to each other as far as functionality. So I always like to go to it next. So what we're going to do is we're going to edit rung 0. And we can right click and start pinning rung edits. And then what we want to do is double click where it says TON. And we actually get a drop down right there. And 2 down from it is the retentive timer on instruction. So we're going to select it and put that into our program. Now, maybe somebody one day will tell you the history of the PLC and why it's actually called this, but the RTO instruction stands for retentive timer on. But all data in the Control Logics and Compact Logics PLC is retentive. But this causes a lot of myths by it simply being called that. But right now we have switch 1 off. Our EN is a 0, our TT is a 0, our DN is a 0, and our cumulative value is a 0. And to start with, I'm going to simply switch 1 on, and immediately we do get the EN and the TT. And 5 seconds later, the blue light came on. 10 seconds later, we're done. And our TT goes out, and it sounds like it's exactly the way the the TON works. Except when we switch 1 off, it stays where it is. The accumulated value stays where it is. The EN dropped out. We switch it back on. It comes back on. But yeah, it won't actually start timing again. Now, you may need to even go back and review the TON on this. But I always tell people the only difference between an RTO instruction and a TON instruction is what they do when they're false. And here's why I kind of stress that for a second about what does the TON do when it's false. Because a TON, when it's false, it's going to write a 0 to the accumulated value, the EN, the TT, and the DN. Our RTO does nothing when it's false. And that's the difference between just thinking things do nothing and then something actually doing something when it's false. So to reset this one, we're going to have to use an external reset. So we're going to add another rung. And we're going to bring down a go look for a 1, examine on, and let's use the blue button. So I'm going to go find local :1 :I, data, and 3. And then on the timer counter tab, you'll notice you have an RES instruction. That is a reset. And we're going to reset our first timer. Also, you reset the entire first timer. A lot of people will be like, okay, well, I need to reset the preset. If we go and we select first timer PRE, we get a red X. It's not going to let us do that. So we always want that entire element. And we're going to put that in. And so now, if we put our blue button, that's going to reset our timer and we are ready to do it again. And we can enable it. And mainly, we didn't actually talk about this part, is since it does nothing when it's false, it stops where it was at. So if I switch it on again, off, then every time it's enabled, it picks up where it left off. So a good example of where you'd use something like this is, see we're going to do runtime monitoring on a motor. Maybe it's a pump and the pump needs greased every 40 hours. Well, we could kind of guess and be like, well, I think the machine runs for 4 hours a day. So every 10 days we need to do maintenance on that. But then we find out, well, no, they added a second shift and we didn't think about that part. So now it's actually running 8 hours a day. And next thing you know, the pump is worn out because we haven't been properly maintaining it. So that's one that you'll see it a lot on. Another is, well, just in general run times, how long has a machine ran for, especially you guys that are having to warranty equipment, is, the customer calls and says, hey, we've only ran this machine 10 hours and it's already, it already seems like, everything's wobbling around on it and squeaking. And you go in there and you find out, well, okay, no, you've ran it way more than that. And yeah, you start asking, okay, now what all maintenance have you done on this? And they're like, oh, well, I didn't, all of a sudden they'll start fumbling on stuff like that. Let's see, where are we at the sea? Tom, hey, well, great to have you from the Netherlands. Huntington Bill, another great video. Well, thank you very much. And guys, I'm sorry, but for some reason we got that emoji going on that last chat. So if y'all can throw something in the chat, I can figure out what the last person said. But all right. Also, I forgot to, actually, I didn't forget. I just, I do it in this order usually is because we end up needing this reset for the RTO instruction. You also can use the reset on the TON instruction. So let's go back to rung 0 and let's change this back to a TON. And we switch which one on. When we switch it off, it goes to 0 because everything but the preset goes to 0. And I guess I didn't actually mention that's exactly the same thing as a reset does. But if I switch which one on, it's enabled. If I hit my blue button, every time I do it, it clears out our accumulated value. Now, I always like this part because I ask usually after this is, okay, when we're doing this, what's happening to the green light and the yellow light? Why are they staying on? And this is a really good thing to do, especially instructor, well, everybody, to talk about program flow, because we see the blue light go out because it wrote a 0 to the accumulated value. And we look and we see the EN looks like it's a 0. In fact, let me go back to that just so you can see. So right now our EN and TT are definitely 1s. I've hit the blue and these go to 0, but notice our lights are still on. Now, one thing that will start making my skin just like absolutely crawl is if somebody right now says, yeah, that's because the last rung wins. No, the last rung does not win. There is a 0 and a 1 getting written to this, but this is a really good one to do as far as understanding timing. Is if you look here, this instruction is going to write a 1 to our EN and our timer timing when I'm hitting the button. In fact, I should have made that switch 1, 2 for this, but okay. So this is writing a 1 to both of these, and that's going to write a 1 to the green light. And then we have the reset down here going back and putting a 0 in. But we have that update rate too. And I have other videos on that, but I always like to do this is now watch what happens when we drag these instructions above those. So all we're doing is flipping the order here. And now when I hit the reset, notice the green lights don't come on. Now, this has all to do with just the particular timing of this program. And if we had a longer program and more time during this live stream, I actually could make it where it flickers. But that's a good thing. That's a really good exercise to do and study on. So you understand that mainly the position of what you have in the program can really affect the outcome that you can get. And while mainly it comes down to how you troubleshoot it usually, because somebody will write a program and they'll manage to get it to work. But when something is broke, that's when you'll see the most incredibly insane things happen. All right, there's one more timer to talk about, and that's the TOF. And it's probably the most misunderstood timer because it's the least used. And it also, again, it does things when it's false, which really makes people struggle a lot. So we're going to change this to a TOF and put that in there. And then let's go ahead and get this back to square one. All right, so we have a TOF here. And right now, switch one is a 0. So this is false. And let's just focus on rung 1, this enable right here. So rung 1, the enable is 0. Our green light is out. And we switch 1 on. Immediately the green light is on. Now notice the accumulated value is not accumulating. But again, I want to stick right here on this rung 1. We're going to wait about 10 seconds just so we can make sure. Let's see. And then we're going to switch 1 off. Now notice you got a lot of action going on up here, but mainly our green light went back off and our EN went back off. So the same as the RTO instruction and the TON instruction, the EN simply means that the instructions preceding the TOF are true. So this goes and looks for a 1. Right now it has a 0, so the EN is off. And we switch 1 on, and it comes on. All right, let's see. What do we got going on in the chat here? Let's see. Excellent, Tom. I've got a question which might be able to solve with a counter. For school, I'm designing an automated tester, but I can't figure out how to sequentially enable pulse outputs with intervals very easy. Huntington Bill's right. Sequencer is a good way to do that. And we actually, one of our most popular live streams is actually answering your question because there are a ton of different ways you can do that. So let's switch over here and find that. Where is that sequence? Yeah, sequencing machines. So I can't remember if there's 9 or 10, but there are 9 or 10 ways to do that in here. So sequencer live. Check that one out when we're done here and see what you got. All right. Let's look at this TT bit now, though. So the TT, right now, our timer is not enabled, and our TT is a 0. We're going to switch 1 on, which is going to enable the TOF. But notice our TT is not enabled right now. And that's because this one, the TT actually becomes a 1 when the TOF becomes false. So we're going to switch 1 off. And now the TT is on, and our cumulative value is going up. And that's the other thing to notice. Even though we have a TOF, and a lot of people are like, well, that's for timing down something. It still times up. So the TT is going to be true whenever the TOF is false and our accumulated value is less than our preset. And then we have the done. So right now, switch 1 is off, our enable is false, and our done is 0. So we're going to switch 1 on, and immediately our done is a 1. So there's a couple of conditions here on the on the TOF to make the done a 1, and that's what really starts to trip people up. So anytime that our first timer is enabled, then our first timer done is going to be a 1. I'm going to switch it off, and notice the done is still a 1. And then after 10 seconds, the done goes to a 0. So the done on a TOF is going to be a 1 whenever the TOF is enabled or when the enable is false and the accumulated value is less than the preset. And I always tell people this is one, if there's ever one for you just to park on for a while and run over and over again, it's this one. Because the other two, really, once you get a TON down, you've got the RTO down as long as you realize an RTO does nothing when it's false. But this one here gets a little tricky. And finally, we got the blue light, which kind of covers our accumulated value. And so we are going to switch one on. And notice our accumulated value immediately goes to 0. And then when we switch it off, that's going to make our TOF false. And that gives us start and the time. And once we're above 5,000, the blue light's going to come on. Let's see. Somebody's going to throw something in that chat. That way I can figure out what excellent Tom is saying here, because I got that YouTube emoji. YouTube, wait. I'm glad they gave us emojis. I'm glad we could interact with you. But it's like, okay, there's like a ginormous heart in the middle of your question there. So I can't tell exactly what you're saying, because I got so basically a TOF. Thank you very much. So basically, well, no. So not quite. And mainly it has to do with the done, because the done is where it gets a little bit grayer. Thank you for the chat there. The done is where it gets a little bit grayer, because you're right. The EN works exactly the same. The TT, mainly, it's going to time when it's false. But then you have the done, and the done's where it gets a little trippy compared to it, because on the TON, the done is going to be true only when it's enabled and our accumulated value is greater than our preset. But on a TOF, the done is going to be true whenever the timer is enabled or the timer is not enabled and the accumulated value is less than the preset. So that's the one thing. And that one's worth just kind of going over a couple times. And I got to be honest, I probably see like 99 TONs to every one TOF. So even when I see it, I kind of have to really work through it in my head to figure out why, not why. Well, sometimes it is, why did they do this? But a lot of times it is, okay, now, when is this going to be true? Because, yeah, mainly that done can get a little tricky. All right. How's everybody feeling about this? And yeah, so if you have any questions on the TON, go ahead and throw them in the chat. We're going to do one more, and actually I'm going to shortcut this one because I'm not going to worry too much about it, but there's a little bit of a difference in how you'll see it in function blocks. And if you have the, I think it's the light version of Studio 5000, or is it the mini? Yes, the mini version. If you have the mini version of Studio 5000, you're not going to be able to do this, but it's not a ginormous deal, but I'd like for everybody to see it. So I'm going to right click our main program, and I'm going to add a new routine. And our type here is going to be a function block diagram. And I'm going to make the name of this. I'm just going to call it, I was going for FB and I put PB in. There we go. FB for function block. And remember that the main routine is the only one that's going to be executed by default. So in order for us to get this function block routine to run, we're going to go to our main routine and we're going to bring down a new rung. And another way we can do this is instead of going and even finding the JSR, which is going to be over a program, we can just type JSR, and we can press the enter key. And that's going to insert that instruction for us on that line. And I'm going to select function block, and we'll get that in there. Actually, it's not that important that this is running because we're going to probably, unless somebody has a specific question, we're not actually going to go all the way into this. I'm just going to put a rung edit in, and I am going to go to the timer counter tab. And notice we have the same basic 3 instructions. We have a TONR, a TOFR, and an RTOR. And the major difference in these compared to ladder logic is this reset right here. So we have a reset instruction in ladder logic, and function block programming, we only have the one instruction and everything is built into it. So if you wanted to reset it, you would just put that blue button right here. But beyond that, it works identical to the way they work in ladder logic, so I'm not even going to bother. I'm just going to drop this in just in case somebody has a question, and we're going to go right back to the main routine. Because next we're going to talk about counters. And let's see, what's the easiest way? Okay, I know this may be the longer way, but honestly, I think every way that I do this, otherwise we're going to get a little bit confused, is we're just going to highlight all these and hit the delete button and put that in there. And we're going to start fresh on the counter. So I'm going to bring a new rung down. And we're going to go to our favorites and bring down a go look for one, examine on. And we're going to look at local colon 1 colon I data 0, which is our green button. And then we're going to go to our timer counter tab. Also, I would love for somebody to tell me what I've done. This happened recently. And I think if you even go to the beginning of the live stream, I can't remember for sure. I believe these actually said timer counter compare. They are actually spelled out. But the moment I click into them, for some reason, all these get really small and you kind of get a mouse over to figure them out. So if somebody could tell me what I did to cause that, it didn't used to do that, but I did something. But we're going to bring down a CTU instruction. And we'll just call this one our first counter. And we're going to right click it and new. And we'll go ahead and make our preset 5. And then in conjunction with that, we're going to bring down another new rung. And we're going to go back to our favorites and bring down a go look for a 1. And we're going to go find local colon 1 colon I data 1. And this time we are going to bring down a CTD countdown counter. Only this time we are actually going to go find first counter again. And a lot of people will tell me, well, you can't do this. Well, no, you absolutely can do this. There's absolutely nothing wrong with it. And first, let's just put that in. Actually, but no, we'll go ahead and put some more in. But after we typed first counter, we had to create it. So let's right click first counter and fourth one down. Let's monitor it so we can see what it did. So when we did that, we created the structure right here, which includes a CU, CD, DN, OV, and UN. So let's go ahead and bring those into this. So new rung, and we're going to bring down a go look for a 1, examine on, and an output energize. And we are going to find first counter, and we're going to look at the CU. And for that one, we're going to turn on local colon 1 colon O dot data dot 0, which is our green light. And let's go ahead and copy and paste that 3 times. So on the second one, we're going to grab the CD. The third one, we're going to grab the DN. And finally, we're going to grab the OV. Oh, and well, we can't leave the UN out. So no, let's go ahead and do one more. Even though we don't have a light for it, let's copy and paste that one more time. Let's grab the UN. And over here, we're going to grab the yellow light, the red light, the blue light, and just an output. We're just going to grab, we're going to grab output 4, just so we got somewhere to put the U in. And that'll get all those in there. So we'll put that in. And forgot to put a count in. Or accumulator. Okay. So we have a CU and a CD. And then we have the DN, the OV. So first, a count up counter is on the green button. So I'm going to press the green button. And when I do, our count up goes up. And also, notice when I press that green button, we're also getting the green light. And if we look in here, that's because the CU bit turns on when we press the green button. So unlike the timer from earlier, it had the E in. Well, in the CTU and CTD's case, we can be counting up or we can be counting down. So this is how we track and remember that we count. Because one, and hopefully everybody realizes this if you went through the first one, is this is running incredibly fast. So if we go and we right click our main program and go to properties and we go to monitor, we're running roughly 20 microseconds or 20 millionths of a second. So every 20 millionths of a second, this is blowing by this. So it has to remember that it's already counted this, and it's using that CU to remember that it's already done it. So that's how it tracks it with that. But we press our yellow button and it counts down and we see the CD highlight. Also, while we're at 0, we're going to press the yellow button again. And notice that we can count into the negative direction. So we can use counters and we can count up and we can count down into the negative. And if we bring this up to 4, then the next time we press it, if we look at the red light here, our red light is going to come on. And that means simply that the accumulated value is greater than or equal to the preset. So I press the green light again. I'm sorry, the green button again. And our count goes up to 6. Our red light stays on, and literally it will stay on forever if you're going up. But notice if we bring it back down to 5, then I hit it again, it's going to go to a negative. I'm sorry, I'm reading Tom's comment at the same time. The red light is going to go back off. All right, let me see what we got going over here in the chat. So yeah, one, go ahead and feel free to say hi in the chat, ask any questions, even if they're not timer and counter related, because yeah, usually some really good conversation comes out of this. In fact, I believe Tom probably has a really good question here. And also, yes, if you didn't know it, we do these live streams often. And if you want to know about them, go ahead and hit that subscribe button and tap that bell. But all right, well, let me catch up on this. Let's see. Too many versions. Let's see. Tornado, I'm not sure what we're talking about there. Are we talking about the 3 different timers and counters, or are we talking about Studio 5000? Because that does get difficult. Even when I was creating this, I don't know if anybody noticed, we have version 35 and 32. Well, yeah, that means there were 33 other versions that we'd have to fight in Studio 5000. But yeah, that can be really difficult there. Okay, the TOF is working the same way as your car light when you're exiting. Oh no, I can do the same thing with a TON, and that's the interesting. Man, I wish I had caught that comment earlier. In fact, that's worth yeah. Let's put that on the list. I am gonna hit that one because that's what people kind of get. Let's see, TON car light. I can actually do anything you need to do with a TON. And honestly, and here's where I hate to throw programming rules, but I rarely use the TOF because really once somebody understands the TON and they see it throughout your program, then you can make it do anything. But that's a good one there. I wish I caught that one earlier on ahead, but I'll pop that back up. Let's see. Yeah, timer overload. Huntington built. Not sure. I don't know what that one means. Timer overload is in. Yeah, okay. I probably gave you way too much info in timers. Hey, Mibab Ali. Probably butchered your name. Sorry, but yeah, great to have you from India. Let's see. Does the preset value also apply to respective negative value? And so, yeah, let's change our preset. We're going to change this to a -5. Whoops, that's accumulated. So now we're going to make our preset -5, and immediately our done bit becomes a 1 because -4 is greater than or equal to a -5. But now we can sit here and start bringing this down. And when I get to -4, our done is still on. And we hit it one more time. Now it's equal, so the done's still on. But when we go to -6, it'll drop out. Does that answer your question there, Tom? All right, we got one more to talk about. And these aren't as important as they used to be, but they're still important. So used to an RS Logix 500, you could only count up to 32,767. And in the lifetime of a machine, or depending on what you're building, sometimes in the day of the machine, you could easily get up over that. So we have the OV and the UN. And one of the most funny classes I ever had, actually, they were a great group, but the oldest one I think was 25 years old, and I still laugh every time I think about it. Is so I asked them, I'm like, have you ever seen an old school odometer, mechanical odometer? What happens when it gets to 99,999 miles? And they all looked at me like the deer in the headlights. They'd never seen a mechanical odometer before. But if you've ever seen a mechanical odometer, when it hits its maximum value, it rolls over to its maximum, or I'm sorry, rolls back over to zero. Now, counters almost do the same thing, but they're actually going to go from their maximum positive number to their maximum negative number. And so if we go back over here and let's go ahead and, if you didn't know it, well, the crazy numbers I have off the top of my head, probably a few of you know this number, but we're going to put 2,147,483,000, and the magic number is 647, but just so we get a little bit of time on it, we're going to put in 645. So we're going to say that we've counted, oops, what did I do wrong? Apparently I typed something wrong. 2,147,483,647. Or actually, I wanted 45 though. Oh, well, I typed something wrong last time. Oops, this ever I put it in the preset instead of the accumulated. So Control X, we'll put you back at 5. And we're going to put you right here. So we're almost at the edge of rolling over. And so now I'm going to press the green button. And that's going to take us up to 646. And then I'm pressing it again. That's going to take us up to 647. And pay attention to the OV as I hit it again. Our OV is going to come to a 1. And notice that our accumulated value now is a negative 2,147,483,648. And if I hit the green button again, now we are counting up, but we're counting up from the maximum negative number. A couple of observations about here is a couple of observations. First, notice our first counter dot done is still on, even though our accumulated value is now less than our preset. And the main reason for that is because of this OV. So it knows that it is counted from the maximum negative number. I mean, from the maximum positive number. And so if we right click this and we toggle this bit, then our red light is immediately going to go off. And toggle it back on. So this, if you see this flag, and you don't see this as often, or well, let me take that back. You will see it in programs that have been converted from RS Logix 500. Is used to, this was a big deal. So all of a sudden you'd see the OV and you'd see a bunch of funky math going on, because really you need a second counter now to count how many times you've made it to 32,767. Then you got to do a bunch of math. And so, yeah, you'll see that. Now we also have the UN. It's the exact opposite. So when I'm going to go and toggle this bit again, and in our cumulative, actually we don't need to. Our cumulative value is already nearing its maximum negative number. So yellow, we're going to bring it to 647. All right. And then we get it 648. And when I hit it one more time, you're going to see it go from the maximum negative number to the maximum positive number. And that is when you're going to get this UN right here. And that tells us that we have gone too far the other way. Now, notice, now our accumulated value is greater than our preset, but our done doesn't come on. And that's because of this UN. And I did have this happen one time. I had a machine, and really it was that kind of deal. Nobody had really accounted for the UN, and it finally had hit its maximum number. And the way they had set it up, they weren't using the reset. They were actually just changing the accumulated value, and also the done bit wouldn't work anymore. And so be able to look out for that. All right. Now, in function block, it does work a little bit different, and it's worthwhile to do. So we are going to go back to our function block program, and we're going to start a sheet edit, and we're going to bring down the CTUD. And so this combines this count up counter and this count down counter into one nice package right here. And so just so we can see a little bit of it, we'll go ahead and bring this in. In fact, we're going to do this one really short. We're just going to bring you in. We're going to bring you in. And then we're going to go find local colon 1 colon I dot data dot 0. And local colon 1 colon I dot data dot 1. That gets us set up exactly the same way. And we'll go ahead and just put that in. Not going to worry about the rest of it. And then we're going to hit the dialog box up here on the CTUD because you can see all of it here. Also, one nice thing about function blocks, they give you a lot of good info out here. And now I'm going to hit the green button and we see the CU enable, which is where we put the local colon 1 colon I dot data dot 0 in. It has a 1 in it now. And also we have the CU bit internally. Still, it's right there. That's how it's actually tracking it. Oops, I forgot to put a preset in. So we'll go ahead and, well, since I didn't put a preset in, our done is already a 1, but we will go ahead and put a 5 there. Now, these are not immediate when you hit the enter key. You notice our done is still on because we do have to hit the apply button when you do it this way in function block. And now, though, we can go up, we can go down, it can count into the negative exactly the same, and we go up to 5, and now we do have the done bit. So from that point, it works exactly the same. Now, let's see. Where is it? Oh, yeah. Alex, your question is well worthwhile. I'm going to everything. I am still swirling up here on mine, though, so. And I'm wondering, oh man, okay, I don't know if that means it's like buffered and now y'all are hearing what I did say, or, oh, good. Thank you. I'm glad to hear I'm back, Tom. Sorry about that. Don't know what happened, but I do see I see a yellow warning. I probably should be recording this screen because then I could send it off to Michael in Finland and he'd be like, you need to do this. But yeah. All right, but I wanted to do that dimmer. So I don't know exactly where it was at, but Alex wanted to, he was like, the dimmer works like a TOF, but I'm going to show you that we can do that with that. So I'm going to, actually I wanted the selector switch again. And then we are going, actually, yeah, we are going to go ahead and take all this back out because it's just easier. Actually, no, here's a good example of what we are going to do. I'm going to bring another instruction down and we are going to put a JMP in. And I'm just going to call this my timer. And then I am going to drop a new instruction down here with an LBL, which is a label. And this will be timer. And then you have to have an output instruction. So we are just going to go to our favorites tab, drag anything down. And here's another thing you do. You can highlight the shape of something like a go look for a 1 and type NOP. And that's just going to jump over that code. That way I don't have to worry about it for now. This is not a good practice in a normal program, but just in case somebody has a question about a counter. So now we're going to go back up here to the dimmer. And we're going to have a new dimmer. It is going to be a timer. And we are going to bring down another rung. And we are going to look for a 1 and I'll put energize and mainly, okay, we're going to talk through the green light. So that's going to be local colon 1 colon O, oops, data and 0. Might need to talk through the jump label here. That's actually a really good one too. But okay, same thing. So we're gonna make our dimmer light. We want it to stay on for 10 seconds, which is gonna be 10,000 milliseconds. And we want it to happen when the door shuts. Now, I don't know how we want to work the door there. I believe it would be this way. It's because, yeah, the door switch would close. And so then we would need dimmer dot TT. So that right there would actually get you through it. So my door is open right now and our green light is off. I close my door and my green light comes on. And 10 seconds later, it goes back out. So I could do the exact same thing with a TOF and a little bit of massaging of this code. So really it's more of just knowing that the two exist because you can actually I can't think of a single bit of logic that you couldn't do with both of them. So I'm sorry for that final little hiccup in this live stream, but that is the end of it. And we are right at the 2 hour mark. I mean, at the one, gosh, it's been an hour apparently. It felt like two, but we are right at the 1 hour mark, which is where I wanted to end this live stream on. So if you like this, and please hit that like button and make sure you've subscribed and tap that bell because yes, for the last 3 live streams, y'all's biggest complaint was, well, I wish I could have been in the chat. Well, you know, if you're watching this and you don't have that chat over there, that's because, yeah, you didn't hit that subscribe. Talk to you later.